This video, we're going to talk about related rates. Got lots of related rate problems to talk about here. Almost all of them are word problems, and we'll need to know some geometry formulas for some of them. So if your teacher gave you a geometry supplement formula sheet, you might want to have that handy to work through some of these problems when we get to some of our area and volume and perimeter problems and things like that. So let's go ahead and get started here. In question 1, we want to find dy dt and then find dx dt with the equation y is equal to the square root of x. First, we want to find dy dt when x equals 4. So let's do that first. And we're given that dx dt is equal to 3. So y is equal to x to the 1/2. So dy dt is equal to 1/2 x to the negative 1/2 times dx dt. So that is dy dt is equal to 1/2 times the square root of x times dx dt. So dy dt, given these conditions here, it's 1/2 times the square root of 4 times 3. dy dt is 1/2 times 2 times 3/1 is 3/2 times 2 is 4. For part B, we still have the same equation, y equals the square root of x, but they want us to find dx dt. When x is equal to 25, given that dy dt is equal to 2. I'm going to take the same derivative that I found implicitly here, dy dt is 1/2 times the square root of x times dx dt. Now I would like to solve for dx dt though. So 2 times the square root of x times dy dt is equal to dx dt. So dx dt is 2 times the square root of 25 times dy dt is 2. So that's 2 dx dt. 2 times 2 is 4. Square root of 25 is 5, and 4 times 5 is 20. Let's go ahead and look at number 3 now. Number 3 says that x, y equals 4. Part A wants us to find dy dt when x equals 8, given dx dt is equal to 10. So we can use the product rule here. Y dx dt plus x dy dt is equal to 0. So let's find dy dt when x is 8. If x is 8, 8 y is equal to 4, y is equal to 1/2, when x equals 8. So 1/2 times 10 plus 8 dy dt equals 0. This is 5 plus 8 dy dt equals 0. 8 dy dt is equal to -5, and dy dt is equal to -5/8. For part B, we'll define dx dt when x is 1 and dy dt is equal to -6. So we have the same relationship, y dx dt plus x dy dt equals 0. But now, given that x is 1, we have 1 times y is equal to 4, so y equals 4. So y is 4, dx dt is unknown, plus x is 1, dy dt is -6. That's 4 dx dt minus 6 equals 0. 4 dx dt is equal to 6, and dx dt is equal to 3/2. Let's look now at number 5. It's an area problem. So the radius of a circle is increasing at a rate of 3 inches per minute. Notice that inches is a measure of the radius and minutes is a measure of time. So the rate right here has a unit that tells me that rate, inches per minute, is dr dt. Find the rate of change in the area. When r equals 6 inches. So let's find that first. So dA dt is equal to 2 pi r times dr dt. dA dt is equal to 2 pi times 6 inches times 3 inches per minute is going to give me 2 times 6 is 12, times 3 is 36. Inches times inches is square inches per minute. Don't forget your multiplier of pi there. It's exactly 36 pi square inches per minute. Part B asks me to find dA dt when r equals 24 inches. So dA dt equals 2 pi times 24 inches times 3 inches per minute. 2 times 24 is 48. 48 times 3 is 24. 12 and 2 is 144. dA dt equals 144 pi square inches per minute. Square inches is a unit of area. Minute is a unit of time. So it makes sense that I have an answer of square inches per minute for dA dt. That was number 5. Let's go ahead and look now at number 7, which is another area problem. Again, the area of a circle. 7 says, let A be the area of a circle of radius r that is changing with respect to time. So A equals pi r squared. dA dt is 2 pi r dr dt. If dr dt is constant, is dA dt constant? So no. If dr dt is constant, that means the radius is changing and dA dt will change because the radius changes there. So so let's show the math for that. No. If dr dt is constant, then dA dt is equal to 2 pi r dr dt, as I already said. So dA dt is proportional to r. If this is a constant, k, if dA dt is equal to 2 pi r, k is a constant, then dA dt is proportional to pi, and k are all constants here, is proportional to r is my variable on that side. So, and it's directly proportional that as r increases, dA dt increases, as r decreases, dA dt decreases. Let's go ahead and look at number 9 with volume. A spherical balloon. So spheres have a volume of 4/3 pi r cubed, is inflated with a gas at a rate of 10 cubic feet per minute. So that's dV dt, 10 cubic feet per minute. Volume is measured in cubic feet. Time is measured in minutes. How fast is the radius of the balloon changing? When part A, r is equal to 1 foot. Part B, r is equal to 2 feet. So dV dt is equal to 4 pi r squared dr dt. For part A, we have 10 cubic feet per minute is equal to 4 pi times 1 foot squared times dr dt. So 10 cubic feet per minute is equal to 4 pi square feet times dr dt. 10 divided by 4 pi, and then cubic feet divided by square feet is feet per minute, is equal to dr dt. That's exactly 5/2 pi. Feet per minute is dr dt. For part B, when R is 2 feet, 10 cubic feet per minute is equal to 4 pi, and this is going to be 2 feet squared times dr dt. Problem up here, 10 cubic feet per minute is equal to 4 pi times 4 square feet times dr dt. 4 times 4 is 16. Pi square feet times dr dt. 10 over 16 pi feet per minute is equal to dr dt. It's going to be 5 over 8 pi feet per minute. Okay. That's it for number 9. Let's look at number 11. Number 11 is a cost, profit, revenue problem. So we have a company that manufactures sports supplements, calculates its cost C and revenue R can be modeled by the equation C is equal to 125,000 plus 0.75x, and R is equal to 250x minus 1/10 x squared, where x is the number of units of sports supplements produced in 1 week. Production during one particular week is 1,000 units and is increasing at a rate of 150 units per week. Find the rate of change of cost. So dc dt is going to be 0 plus 0.75 dx dt, or 3/4 times dx dt. dc dt is going to be 3/4 times dx dt is 150. And so this is 4 goes into here. This is 75, and this is 2. This is 52.25 over 2 is 112.50 dollars per week, because cost is in dollars. $112.50 per week. dr dt for part B is equal to 250 minus 1/5. This is dx dt, and this is dx dt. So dr dt equals 250, dx dt is 150 minus 1/5 times 1,000 times 150. I'm going to pull that 150 out front and make this 200 here. 250 minus 200 is going to be 150 times 50. 0, 0, 25. 5 and 2 is 7. This is dollars per week. So now we did not have the profit equation given to us. We need to make it. But our profit equation P is equal to R minus C is 250 x minus 10x squared minus 125,000 minus 3/4 x. So P of x is equal to 1,000 minus 3 is 997 x over 4 minus 1/10 x squared minus 125,000. So dp dt is going to be 997 over 4 minus, this is dx dt, minus 1/5 x dx dt, and then that's minus 0. So dp dt is 997 over 4 times, and dx dt is 150. It's 1/5, x is 1,000, dx dt is 150. This is 2, this is 75, this is 200, and, or actually let's go this way. 1,000 here, 5 goes into 150 30 times, so 30,000 here, and that is a big number. So let's go ahead and calculate that off to the side. 997 times 75 divided by 2, 3,737.50. Minus 30,000 is going to be equal to 7,387.50. This is going to be per week. So that was number 11. Let's go ahead now and look at number 12, another cost, revenue, profit problem. Company that manufactures pet toys calculates that its cost and revenue can be modeled by the equation C equals 75,000 plus 1.05x, R equals 500x minus x squared over 25. Let's just write our profit function now. Revenue minus cost. Okay. So that makes this P is equal to 498.95 x minus x squared over 25 minus 7,500. So x is the number of toys produced in 1 week. Production during a particular week is 5,000. And increasing at a rate of 250 toys per week. Okay. Find the rate of change of cost. DC dt is 1.05. dx dt is 1.05 times 250. 1.05, 0, 25, 12, 0, 0, 0, 5, 2, 0, 5, 2, 6, 2, 2 decimal points. So this is equal to 262.50 per week. Part A, revenue, dr dt is 500 dx dt minus 2x over 25 dx dt, or 500 minus 2 over 25x dx dt is another way to write that. X is 5,000, so that's 200. 200 times 2 is 400. So 500 minus 400 times 250 is 100 times 250 is 25000. That's $25,000 per week is DRDT, and DPDT is going to be 498.95 dx dt minus 2x over 25 dx dt, and then that's minus 0. So when x is going to be 5,000 and let's see, it's 498.95 minus 2x over 25 times dx dt. 5 minus, let's see, x was 5,000. So that is 10,000 over 25. That's 400. Times, and this is dx dt is 250. So this is 98.95 times 250 is 45 and 2 is 47. 40 and 4 is 44. 45 and 4 is 49. 0, 0, this is 10. 18 and 1 is 19. 16 and 1 is 17. 18 and 1 is 19. 0, 5, 7, 13, 17, 14, 2, 1, 2, 3, 1, 2. That's just 250, right? Yeah. 1, 2 decimal points. So this is 24,737.50 per week. So lots of profit. Look at all that revenue of 25,000. Nearly all of that is profit because, and we could have just taken this and said the easy way to do this is dp dt is dr dt minus dc dt. So I could have taken 25,000 minus 262.50, and I could have borrowed here and said that this is 49991, and that's 50, and that's 7, and that's 3, that's 7, that's 24, 24, 737, 50. It's the same answer. I just wanted to do it with the calculus there, but really all you've got to do once you've got your, because P is equal to R minus C, that means dP dt is going to be dr dt minus dc dt. So once you have the two, you can just subtract them to find, once you have dc dt and dr dt, you can find dp dt by finding the difference. Let's go ahead and look at number 13. The revenue from selling X units of a product is given by capital R is equal to 1,200X minus X squared. Sales are increasing at a rate of 23 units a day. Find the rate of change of the revenue when X is equal to 300 units. And so let's go ahead and do that. dr dt is equal to 1200 dx dt minus 2x dx dt. So dr dt, given these conditions, is 1200 times 23 minus 2 times 300 times 23. So 23 times 1200 minus 2 times 300 is 600, is 23 times 600, 0, 0. 6 times 3 is 18. 6 times 2 is 12, plus 1 is 3. So this is $13,800 per day, because a unit of time here is a day. All right, B asks us to do the same thing, but we want now for X to be 450 units. So dr dt, 1200 dx dt minus 2x dx dt. Remember that dx dt is 23. So we have 1200 minus 2x dx dt is dr dt. So dr dt is 1200 minus 2 times 450, that's 900, times 23 is 300, times 23 is $6,900 per day. All right. Supposed to do number 14 next. That's about profit. Profit P from selling X units of production is given by P is equal to 510X minus 0.3X squared. Sales are increasing at a rate of 9 units a day. Find the rate of change of profit. When X equals 400, so dP dt is equal to 510 dx dt minus 0.6x dx dt is equal to 510 minus 0.6x dx dt. So when x equals 400, we have 6 times 40 is 240, so 510 minus 240 times dx dt is 9. 510 minus 240 is 7. 270 times 9 is 63. 18 and 6 is 24. Is $2,430 per day for change in profit. And when X is 600 units, we have, so that would be 6 times 60 is 360. So 510 minus 360 times 9 is 510 minus 360. That's 5. So 150 times 9, 45. 9 and 4 is 13, is equal to $1,350 a day. Okay. So let's go on now, look at our next suggested problem, which is number 17. You've got a nice picture of this in your book if you want to make reference to this. Try and draw a picture here that we have a right triangle going on here. We have the dot, the pier is up here, that you have a rope attached to here, and you're attached to the boat is down here, and the pier is 12 feet above the surface of the water here, and this rope is 13 feet long at this point in time that we are starting at, but the winch that's up here is pulling the rope in at 4 feet per second, so that the boat is going to get closer to the to the dock there. So we need to look at this. This is going to stay a right triangle here. And we have 12 is going to stay constant here. So 12 squared plus, I'll call this x squared is equal to r squared, where r is going to be the length of my rope. And this is a constant 12 feet that doesn't change. 12 squared is 144 plus x squared is equal to r squared. Let's take the derivative with respect to time. 2x times dx dt is equal to 2r times dr dt. And so when 13 feet are out, this is a 5, 12, 13 right triangle. Let's figure that out with the Pythagorean theorem though. 144 plus x squared is equal to 13 squared. 144 plus x squared is equal to 169. Subtract 144 from both sides, and I get x squared is equal to 25, making x equal to 5. It has to be a positive 5 since x is a distance. So this is 5. So we're going to say 2 times 5 is 10 times dx dt is what we want to find, is equal to 2r. So 2 times 13 is 26. dr dt is a negative, since we're pulling it in, a negative 4 feet per second. So 10 dx dt is equal to a negative, let's see, that's 24. 8 and 2 is 10 feet per second, and I get dx dt is equal to negative 10.4 feet per second. So then they want us to say what happens to the speed of the boat as it gets closer and closer to the dock. So as r is getting smaller here, dr dt is staying constant at 4 feet per second. The r is getting smaller. This is getting smaller here. X is getting smaller. Dx dt has to get bigger though to balance it out and keep this side the same. So as x approaches 0, dx dt increases. So let's see if we can solve this for dx dt to show you that. Dx dt is equal to 2r dr dt over 2x. So as I'm dividing by a small number, getting close to 0 here, division by a fraction makes this get really big really quickly, so that r is pretty insignificant, but it's getting smaller, but this is getting smaller a lot faster. dr dt is staying constant, so this is basically a constant divided by a really small number, is this idea of it's shooting off to infinity here, like this, with this idea of 1 over x. As I get close to 0 from the right, it's going off to positive infinity. All right, let's turn the page here. We've got lots of these problems. This is a long video. So go ahead and look next at number 22. Number 22 is advertising costs. And it says a retail sporting goods store estimates that weekly sales S and weekly advertising costs X are related by the equation S is equal to 2,250 plus 50x plus 0.35x squared. The current weekly advertising costs X are 1,500. These costs are increasing at a rate of $125 per week. Find the current rate of change in the weekly sales with respect to time. ds dt will be 50 dx dt plus 0.7x dx dt. So that's going to be 50 plus 0.7x times dx dt. So what ds dt will be. So ds dt under these conditions is 50 plus 7/10 of 1,500. 1,500 times 7/10, 0.035, it's 10. So that's going to be 1,050. dx dt 125. So ds dt is 1,100 times 125. 1,100, 125. Let's do it the other way. 0, 125, 0, 125, 0, 7, 3, 1. So ds dt should be 137,500. This is dollars per week. Let's look now at number 24. Company is increasing the production of a product at the rate of 25 units per week. Demand and cost functions for the product are given by little p is price, 50 minus 0.01x, where x times p is equal to 50x minus 0.01x squared is equal to my revenue function. My cost function is equal to 4,000 plus 40x minus 0.02x squared, where x is the number of units produced in a week. Find the rate of change of profit. So capital P is equal to revenue minus cost. P x is equal to 50x minus 0.01x squared minus 4,000 minus 40x plus 0.02x squared. So we have 0.2 minus, or 0.02 minus 0.01 is 0.01x squared. At 50 minus 40 is 10x minus 4,000 for our profit. So dp dt is 0.02x times dx dt plus 10 times dx dt minus nothing. So this is 0.02x plus 10 times dx dt. X is X is 800 units. So 2 times 8 is 16 plus 10 times 25 is 26 times 25, 30, 13, 12, 5, 650 dollars per week. All right. And let's move on now to the next problem. And this will be our last one for this video and this section. We did all of them together in one video. We also have number 26 to do as a suggested problem, but I'll leave that for you to do on your own. I'll finish up with number 25. Profit of a product is increasing at $5,600 per week. The demand and cost functions for the product are given. P is equal to 6,000 minus 25x, which means that revenue is equal to 6,000x minus 25x squared. Cost function is 2,400x plus 5,200, and X is the number of units produced in a week. Find the rate of change of sales with respect to time. So find dx dt when the weekly sales are 44 units. Okay. So we have dPdt is going to be negative 25 dx dt, and we have no, I'm sorry. Do it this way. dr dt is 6,000 dx dt minus 50x dx dt. And dc dt is 2,400 dx dt. And I want to find the difference in them. dp dt is going to be 3,600 dx dt minus 50x dx dt, and that needs to be equal to 5,600 So we have dx dt is unknown, 3600 times negative 50x times dx dt is equal to 5600. X is equal to 44. So that's 2200. 3600 minus 2200 dx dt is equal to 5600. So that is 1400 dx dt is equal to 5600. 56 divided by 14 is 4. Dx dt is 4. That's 4 units per week. All right, that finishes up this video, and that wraps up all of our topics for chapter 2. We'll come back next time and start talking about our topics from 3.1, which we'll talk about increasing and decreasing functions, how we can use the derivative to tell us whether the slope of a function is positive or negative in a particular interval, and tell whether it's increasing or decreasing. In pre-calculus, we had to have the graph and look at the graph. Now we're going to use the derivative function to help us figure that out. We can go back to our sign charts that we did in pre-calculus part 1, where we before were interested in where the function was above and below the x-axis, where the y value is positive or negative. Now we're going to be interested in where y prime is positive or negative, and that will tell us where a function is increasing or decreasing. So we'll come back and we'll talk about that next time in the beginning of our applications of derivatives. See you for the next video.